Okay, so in section 9.3, which was the previous section, we started thinking about equations, what the equal sign means, and we also started to think about conceptually representing and solving equations by using pan balances. This section, which is 9.4, really just builds on and adds a new option for a representation. So instead of pan balances this time, we're going to be looking at strip diagrams and how we can think through algebraic problems with a strip diagram and make sense of the steps that way. Okay, so here's one of the example problems from your textbook. And I really wanted to make sure that we talked through an example problem from the text because I think it's actually a little bit misleading when you read the problem and then in the textbook in the chapter, it's just like the solution is just right underneath the problem and you haven't necessarily taken any time to think through how did they build this solution. So I wanted to in effect slow it down a little bit for us and really think about how do we create these equations and models. Um, how do we create these equation and models after reading the problem? So here is the payment plan problem. The Browns are buying a TV that costs $1,300. Wow, exciting day for them. After they make 4 equal payments, they still owe $400 on the TV. How much was each payment? Okay, so what I like to do is I always start out by identifying the goal. This is the goal. And another way to say this is the goal is I want to find out the cost. I want to find the cost of one payment. And I'm going to use the letter P for payment. I know your book uses X. I like to play around with the letters that we use for variables and point out that we can be flexible about it. So I'm going to use P for payment. Okay, so let's start to think about this in a strip diagram format. So with a strip diagram, it's really helpful to identify the largest amount in the problem or the total amount so that you know what is your whole bar going to stand for. And in this case, I think $1,300 is our total. So this whole bar length is $1,300 and I'm going to start building my equation over here while I build my strip diagram. Okie doke. So $1,300, what is that equal to? It's equal to the 4 payments and 400 more. $400 more. So let's see, I'll just make payment, 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 and then still $400. That represents the whole $1,300. Okay, what happened to my equation? Or what happened with my equation? $1,300 is the same length as 4p plus $400. So you can write 4p or you can write p plus p plus p plus p. Either way is fine. Okay, so we're all set up with our strip diagram and our equation, and now we can think back about what's our goal, figure out what is one payment. So let's go and try to figure that out. So one thing I noticed I could do is start to remove this 400 from the length of my bar model. And over here, keeping both of my sides equal, that would mean that I take 400 away from both sides. So with this strip model, what I have now is 1,300 minus 400. So this is $900 here. 900. And that is equal to my 4 payments. Okay. And now I can see, okay, the length of $900 is equal to my 4 payments. I want to know what one payment is. So here comes division. We're going to divide by 4 to just get what one payment is worth. So that is happening on the equation side. And then if you want to show divide by 4 on your strip diagram, you could do something like this, like we're just taking one of these 4 equal groups, and that is equal to whatever 900 divided by 4 is. Let's think through that. We're going to make a thought bubble over here. Sure, you could get out your calculator. That's fine too. That's my thought bubble though, and I'm going to think through 900 divided by 4. Well, I can think through 800 divided by 4 is really easy for me to think about. That's, I'm thinking about like 8 divided by 4 is 2, so 800 divided by 4 would be 200. And then I would still have to remember that I have 100 more of my 900 to divide, and 100 divided by 4 is pretty straightforward as well. So that will give me 125. Nope, 225. Oh dear. My eraser got out of control. Let's fix this. 200 plus 25, 225. Finish off my equation. We did it. And now I know this length here is worth 225 because 4 groups of 225 make 900, and then that $400 more would get us back up to the $1,300 price of the television. Okay, let's think through another example together that's got a little bit of a different structure. So this problem says a school has 2 hip hop dance teams, the Jaylani team and the Zuri team. There are 1.5 times as many students on the Jaylani team as on the Zuri team. Altogether, there are 65 students on the 2 teams combined. How many students are on the Jaylani team? How many are on the Zuri team? Solve this problem in 2 ways, with the aid of a diagram and with algebraic equations, and we're going to relate the 2. So that is our task. And you can see I've done a little bit of setup work. So I thought about, when I was structuring my strip diagram, I thought about what is the total amount here? What is going to be the length of my whole bar? And I decided that since altogether we have 65 students, that the length of my whole bar would be 65. And that is equal to the amount of students on the Zuri team combined with the amount of students on the Jaylani team. So it's Zuri plus the Jaylani. And then I realized, oh, sorry, and I have the Z plus J equals 65 as my starting equation. And then I realized they give us some very helpful information when they relate the sizes of the 2 teams. So there are 1.5 times as many students on the Jaylani team as on the Zuri team. So they're comparing the sizes multiplicatively for us, and they're using the size of the Zuri team as a reference for the size of the Jaylani team. So I could say, okay, Zuri team, I'm just going to call that number of students Z. And then I can call the Jaylani team 1.5Z. It's 1.5 times as many students as on the Zuri team. So it's Z plus another half of a Z, or 1.5Z. And so that J, the Jaylani team, can be replaced with 1.5Z. And that is useful because now I only have one variable in my equation, and I think I can solve it. So altogether, we have 1Z plus another 1.5Z, so that's 2.5Z. We're still equal to 65 here. And now we know we want to think about dividing by 2.5. And you can also think about, if you want to conceptually understand this 1.5Z a little bit differently, we could also think about it as being Z plus another 0.5Z, or a half of a Z. And then when we think about dividing by 2.5, that's just going to leave us with the length of one of our Z's. So let's do that. We're just going to get one of these left when we divide by 2.5. If you want to grab your calculator for this one, go ahead and do that. And I got 26 students. So what does that mean? Zuri, Team Zuri has 26 students. And then if we want to think about, oh, how much does Jaylani have? Jaylani has 26 plus another half of 26. So that'd be 26 plus 13. 26 plus 13. 39 students altogether. So Team Zuri, 26 students. Team Jaylani, 1.5 times as many with 39. And the two added together, we hope, adds up to 65. If it doesn't, we would want to go back and check our work and see where we might have taken a misstep. 26 plus 39. I'm going to move 1 from 26 and tack it onto the 39. So I have 25 plus 40. And that is indeed 65. So really in this section, we're just not just, but we're modeling problems with strip diagrams. And this is another representation to have in your teacher toolbox, and hopefully a way to help you make sense of the steps in algebraic problem solving in a new way beyond the pan balance representation.